So hi everyone, sorry to keep you waiting. And this is the last presentation, and I can see from your eyes that you're all a bit tired and maybe a little bit hungry. It's okay. But I'd like to ask for some more of your attention, please, for the next 15 minutes. It will be worth it. I'm Jerson, and I'd like to begin our presentation by showing you a short video clip.
Hi everyone. This is so good.
So what you've just seen is a 6-second clip of my colleague Turan enjoying playing in the snow. Because why not, right? It's fun. And I know that some of you here have already deep dived into that snow. Cohort 3 has had their fair share of playing with the snow. It's fun to play in the snow. However, there's always another side to the story. Because inasmuch as we are enjoying playing in the snow, on the other side, or other parts of the world, that very snow is melting at a staggeringly frightening pace. And it's not just about the snow anymore. Because in some other countries, in some tropical countries, the heat from the sun is getting hotter and hotter. From where I'm from, the Philippines, natural calamities like typhoons and monsoons, they're getting scarier and scarier, affecting the livelihood of people. What's the reason behind this? We all know it. Climate change. I'm not going to discuss that anymore, because I know that each and every one of us here today knows exactly what climate change is. But if you might not have known some facts about it, I'd like to let you know that 90% of the carbon emissions that cause climate change comes from non-renewable energy resources. Not 50, not 60, 90, almost 100% of it comes from these non-renewable energy sources. But there's always another side to the story, as I've said. There's a positive change in the world right now. Because we've recognized that these non-renewable energy sources are not good for us. So we're transitioning to a more renewable source of energy. That is why, according to the International European Agency, 46% of electricity is expected to be provided by renewable energy sources by 2030. That's great news, isn't it? It gives us hope for the future. However, renewable energy in itself also has its downsides. Because the fact that it is renewable may make us complacent that we can just continuously get it every time, again and again. But that is not the case. Because we found that actually 20% of renewable energy sources are spilled, aka wasted. To put that into perspective, that 20% of energy is enough to power millions and millions of households in Europe alone. Think of it in a global scale. So that's where we come in. Because imagine if you're able to tap into that excess energy that you're unable to make use of anymore and turn it into something more. Turn it into profit, per se. I'd like to present you to e-skimo, where getting energy is as cool as the Arctic. What exactly do we want to offer here? 3 main things. The first one is we want to allow you to bid for energy, finding the energy that you need, bidding for it, and possibly getting it at a better price, a more affordable price for you. The second thing is if you have excess energy, we want to provide you a platform to put it up for listing and turning that excess energy into profit. And the final thing is we all do this in a secure and decentralized manner, powered by our blockchain stack. So if you're interested in how it works, I'd like to call on Haris and Monsef to give you a demonstration of the application.
Thank you, Jerson. So, after working tirelessly for these last 2 days, we'd like to show what we have been working on and surviving the snowstorm as well and having good food. We'd like to start with what we have created in the last 2 days. And it's something that we are proud of as well. So I'll show 2 videos. We'll have one of the videos which will be running the blockchain system, and the second video will show the front end as well. So while we'll be navigating through the front end, the second video which will be on the background, that would be showing you the transactions that would be happening in real time in blockchain. So this is what we created. And we can start the video. And that's the blockchain interface. So basically this is where the transactions would be happening. Okay. Good things take time. So we start. So you can see we have the landing page. And the purpose of the landing page simply is to basically deal with the what, the how, and the why of the application. What it is that we have created, why we have created it, and how it works. That's the purpose of the landing page that we have. And this basically is what the home page looks like. We also have the statistics that we included on the landing page to give more awareness about how serious, as Jerson mentioned, the situation is with what we are dealing with. And now the user also has the option to sign up, but we are starting off just by using the existing user that we had. So we are logging in. And you would also see that it also the user would be associated with a wallet ID. That means it's integrated in real time with the blockchain system. So now the user has logged in, and you can see that this is the dashboard that we have. It includes statistics, what are the listings that are on for sale, what are the stock prices and everything. We are proud of that. And basically what we were supposed to do, we were supposed to create offers that the user could access and bid on those offers, basically buying energy, as Jerson mentioned, that this is the solution to our problem. So the user could bid on it, see the bids that are available, and even the option to post offer. So they would be able to select an amount, and they would also be able to have the expiry date for that when would that certain offer would expire. So right now this is the selection that we have. We are selecting a date that we have these many amounts of units, 345, and this is the starting price as an example that we are setting it up. It's okay.
It's not running the back.
It's okay. For the back end, I'd like you to invite you to see the live demonstration, to see the blockchain in action. So we have the setup ready as well. It's okay, we can minimize. But you can see the transactions that would be updating in real time when we click on submit. It's the Ganache blockchain system that we set up. So now it says the offer has been created and you would see a new entry. It's not clear, so we'd like you to see the live demonstration after the presentations are ended. And then the user can also have the option to bid as well. They can bid on it, they can buy energy, they can negotiate. As you can see, this has been placed with the ID as well, and it's linked with the Ganache system as well. This is what we created in the last 2 days for the problem that we had to have an energy trading platform, which would not only have the option to bid, but also trade energy as well. So over to Munsif to explain more details on how actually the backend is working, how the blockchain is, and how the whole Ganache system is integrated with the UL. So over to Munsif.
Okay. Yeah, so, okay, so the demo is cool and all, but how does that work, so behind the scenes? For that, we have a blockchain. And the blockchain is deployed using a framework compatible with our requirements. So for example, in production, we could be using Hyperledger and Bezu to ensure a proof of authority consensus algorithm. And for us, in our case, for the development phase, we are using Ganache, which is a tool to simulate Ethereum blockchains on our private equipment. And to interact with this blockchain, we use what's called smart contracts. And we manipulate these using the Web3 framework. So we can use this through Node.js, which is our backend, and Omid will cover that in more detail. But at the level of the blockchain, what happens is that the backend is implemented in Web3, which makes calls to Ganache and to the smart contracts in order to interact with the private Ethereum blockchain, or also emulated through Ganache. And basically, what does it do? The smart contract, what does it do? Is it is kind of an interface with the blockchain, which proposes functions we can call. So for example, we can register accounts with the service, we can start auctions, we can bid on them, we can close auctions, and we can also safely transfer the funds, which are like in Ethereum in our case, but we could also build our own token for the application, and this can be extensible as we want. And so basically, this is the smart contract, and Omid is going to explain how we interact with this using the Web3 framework.
Thank you, Monse. So here you can see a semantic model of how our backend architecture works. Every request originates from the front end, and we propose some, basically we provide them with some API routes. We check that the user who is trying to perform an action is entitled to working with that API endpoint. And also we handle any possible errors in the process, and we check that the data is in the correct format. At the core of our application is the controllers. We have some controllers for managing sign up and sign in of the user. But the main part of the business logic that we have is we allow users to create offers. Basically, they come to our platform and say, I have a certain amount of energy that I want to sell. And we allow them to put their offer on the blockchain, and everybody else is able to come and see the offers and put bids on the offers that they want to work with. We also have implemented some utilities to work with both types of storage that we have. We have some MongoDB that we store very basic user data just to keep the state of the application and be able to retrieve information from the Ethereum network, which covers all the transactions and stores everything in form of basically transactions on the blockchain. Now that we have seen the lemons, let's make some lemonade. So sign-up flow is one of the most consequential flows on our application. It starts with a post request on the sign-up API endpoint. We validate the user's request. We want to make sure that the data is in correct format. It's not repetitive. The email address is not something that we have previously had. We create a Web3 account using Web3, as Mosef mentioned previously, and it returns a valid ID for us. After that, we hash the password, we save the user to the database, just some basic information as I mentioned, the username, hash of the password, and the valid ID. And then we need to also register the user on the blockchain. So we perform some calculations of how much it costs for us to save the data on the blockchain, because we have some costs associated in terms of energy that it takes for us to submit a transaction. And after that, we sign and send the registered user transaction to the backend. Upon successful creation, we get the valid ID back, so it's validated and it's basically placed on our blockchain. I want to dive into the details of each function that we have provided in the controller. First, just to give you a general idea, for create offer, we give the expiry date, so we have a desired amount of days or hours that we want the offer to be up. And after that, the offer is automatically resolved, and the highest bidder pays the amount to the person who has created the offer, and basically the amount is added to the account of the creator of the offer. We also have a starting price, so the creator of the offer is able to tell what offer is the minimum that they are willing to accept. And also we have implemented the functionality to end the offer earlier, so that if they don't want to stay until the end of the expiry date, they can end the offer earlier. And to quickly touch on the bids, we have some similar logic in terms of bids. Maybe the most important point is that we are able to list all the offers that we have created. And also we check that the bidder is not the seller, because a person cannot upbid their own offer. And after we do the validations, we submit the transaction to the database, and every person on the platform is able to list the bids. Now, to understand how we create a positive sum game that benefits all the parties, we move on to the true-on section.
So, turning to the business analysis part, talk about a bit of business. So, we've started with the market analysis, And I'm not gonna bore you with some data, so many data, so I'm gonna go through it with shortly. So when we started with market analysis, we didn't think that it will be that impressive. So in Sweden, it's 54% of the energy market cap is from renewables. And also it's mostly from locals. That's impressive. And also when we looked at the growth, we saw that it increased 3 times during 2 years, from 2020 to 2022, and from 3 gigawatt hour to 9.3 gigawatt hour. And also, for the expanding our market, we saw that in European Union, 1 million households in EU are solar powered, and they have some batteries to keep them for some time. And also, coming to the usefulness of our project, what we are proposing to the customers. First of all, we are dealing with households, which brings them cost savings. So they can bid for the cheaper prices of energy, and they can sell it for higher prices. So they can do cost savings through selling and bidding. And as well as when they're dealing with businesses, they can have revenue opportunities as well. So they will have more incentives to build more solar panels in their gardens or yards. And coming to the business side, if the businesses are also joining to our system, the competitive pricing will be the main proposal from our project, because they will have less prices from the households, and they will not be dependent on the governments as well. So they can get their electricity energy from the households directly with a secure and decentralized system. So the big corporations or even the small and larger businesses will be sure that their system will be secure and it will be immutable and also decentralized. And coming to our business model, we thought about the C2C and C2B model. So we have households to households in the microgrid, and also we thought about the businesses that are around the households, that they can be intended to get energy from the households, or some cases, in some seasons, businesses also can give some energy of theirs to households as well. So it will create an increased market and also lower the prices and have more incentives to build solar panels and increase their renewable energy consumption. So, and we set 4.2% of transaction fee model. This is how we earn our money. Coming to the cost-benefit analysis, I want to start with the costs of our application. To build an MVP project after our demo, we need to work more like this guy, like we worked in 2 days, and develop more for maybe 3-4 months more, and probably we need to pay like 50,000 euros. And for marketing and operations, we are thinking these are one-time payments, 50,000 euros and 40,000 euros that we calculate based on the Glassdoor data. And also for the server and infrastructure, which will be scalable from season to season based on the requests. And coming to our benefits, as I said, we have transaction fees based on 4.2%, and we are estimated with 480 users. We are gonna make 20,000 euros for the first year when we are using this much of marketing money. And also, we'll have transaction volume bonuses for big companies, big transactions. So they will get discounts, and they will be intended to make more transactions with bigger amounts, so bigger percentage as well. And also, I want to mention also the non-profit benefit, which will save 100 tons less CO2 emissions, which also should be mentioned. And for the future, for the next 3 years, we want to achieve our break-even point, and with the assumed 60% growth of our project, and we estimated that net earning is over than 43,000 euros. This is based on our assumptions. And also, see you in the future. Future as cool as Arctic with e-skimo. Thank you so much.
Do we have any questions?
Can I ask a question? Because
Yes.
I'm just interested. In part of, for example, 2 users, your system was on bidding base, right? For example, 2 users bid one price, the same price. Which user would you?
Yeah, so the system doesn't allow that.
Yeah,
It's
that
not
won't be-
possible to allow.
So if
In order
the
to
price-
bid, you need to give a higher price. It's like a real life auction.
You can think of eBay as an example. You cannot bid
Is
lower
it in
or
smart
lower.
contract?
Hmm?
Is it written in smart contract?
Yes.
Yeah, yeah.
Yes.
It's all connected. And also, if you want to check the live demonstration of our system, you can just come closer and we can check it together.
The cool part is that the front end and the back end are basically stateless. and all of the logic is happening inside of the smart contracts.
And also
Yeah.
we book just user, so we are keeping only the user in the database, and the rest of them are backed up in the blockchain. So all first beats and all of them are stored in the blockchain part.
Okay, did you have such problem that, for example, I make offer and I buy this offer as well?
No,
Do you
as
have-
I mentioned, we validate that the bidder is not the person who
Okay.
places the offer.
Yeah,
That's the
we'll push
validation
that
that we do.
validation.
Are there any more questions?
Vidya, are you there? Do we have any questions?
Not much.
Thank you.
Thank you.
Thank you so
Thank
much.
you.